Okay, hey everybody, my name is Chris and I am talking to you from Berlin, Europe, if you don't know. Today we're going to be doing a tutorial on Chuck, using Chuck inside of Unity via an awesome package called Chunity. So first up, I'm going to give you a little bit of a background on what Chuck is and why you might want to use it inside of Unity in your projects. So Chuck is an audio programming language, and it's specifically built to allow musicians and artists and sound designers and so on to create expressive kind of audio that can change in real time. And it's made in a way that's quite accessible compared to, for example, trying to write audio code in C or C++ and so on. And in that way, it's somewhat similar to other musical programming environments such as MaxMSP, Pure Data, Reactor, and so on. But the difference with Chuck to those others is that it's an inline programming language as opposed to being a graphical programming language. Now, I really like Chuck. I've been using it for, I guess, 5 years or so. And I find that it's particularly good at doing really highly accurate audio timing, which is often something quite difficult to achieve. At least something I find quite difficult to achieve in Max and Pure Data and a lot of kind of graphical programming languages. And so I regularly come back to Chuck as a great kind of prototyping environment for highly accurate audio. Also, it's just quite a fun little language to program in, and I hope that you'll find it as fun as I do. So one thing I can do is I'll just quickly pull up the page, the Google page for Chuck, so you can see how we might access more documentation about this little programming language. So there's this great site, chuck.cs.princeton.edu, where you can download Chuck, and you can also get this good documentation about the language, about the different kinds of sound making devices in there, and so on. And there's a great community around this piece of software as well. There we go. Another awesome thing that comes with Chuck when you download it is it comes with a programming environment called MiniAudicle, which I can pull up here. Now, MiniAudicle is like a standalone kind of like mini IDE, I guess, for programming and building Chuck patches. So I can pull up, I don't know, we don't have to worry about exactly what's in these, but I can pull up some Chuck. It has nice syntax highlighting and everything, and we can run it all inside of MiniAudicle. So generally, when I'm developing Chuck patches, even if they're going to be used in Chunity, I generally go ahead and prototype them in here if they're getting reasonably complex, because it's just a good little self-contained environment for working on Chuck. There's also a command line option for using Chuck. I'll just pull it up. Here's a big wall of random stuff. So if we type the word Chuck and then the name of a Chuck file, for example, I'm currently in a directory with a handful of .ck Chuck files. We can go ck and then type in, for example, FireLazer. And it didn't get it because it's not ck, it's Chuck. Chuck and then the name of the example. And there's a syntax error in it. Anyway, if there wasn't a syntax error, that would play the sound of this file, or that is described within this file. And this is another good way. In fact, generally using the terminal to run Chuck is a little bit more stable than running it from MiniAudicle. So it's another really good way to get your patches up and running. But specifically for this tutorial, we're going to look at ways to run it inside of Unity. So I'm going to pull up Unity. Let's go Unity Hubs. Very good. And I'm going to create a new Unity project. So, not add, whoops, wrong button. New from Unity Hubs, a new 3D project. And we're going to call it Chunity tutorial. The path already exists. I've already created a Chunity tutorial. Let's make it number 2. Very creative naming. Okay, and here we go. So here is Unity. I use this layout, but you're obviously free to use whatever layout you want. And let's get started. So in order to get Chunity working, or Chuck working inside of Unity, we need to grab the Chuck package from the package store. So in order to do that, we can go Window, Package Manager, not Package Store. Pull the Package Manager up. Whoops, that's not what I wanted. Asset Store is what I wanted. There we go. In fact, I already had it in a tab. And it's connecting. Yep, and we want to look for Chunity. Here we go, Chunity. And we can see it here. And I have already downloaded it, so all I need to do is import it into my project. So I'm going to hit import. All of this is good stuff. We'll import everything. It's going to take a sec. Awesome. So we can now see under project, we've got assets and Chunity and all of the files required to run Chuck inside of Unity. How exciting. And then next up, we need one more thing from the asset store. We need a package called Space Shooter. Space Shooter. And I wonder if I can get it like this. Yep, here we go. Space Shooter free. It should be the first thing that comes up. It's this one, Div Studio Space Shooter. Now, this is just a basic kind of 2D demo project. Oh, importing complete project will override my current settings. Yes. So it's a basic demo project which I found on the asset store, and I'm just using it as kind of a useful thing for us to be able to implement audio assets into. So rather than just making sounds and not attaching them to anything gamified, I thought it would be nice to get them implemented inside of some kind of a game example just for kind of hands-on stuff. Also, sorry about the banging going on behind me. I live above a mechanic that can make some very strange noises. Here we go. Okay, so we're going to pull up a Space Shooter tutorial. So we've Space Shooter template free. I've got it in my assets folder after imported, and we can jump in, go to scenes, and open up the demo scene. So we're going to use this as our kind of blank canvas to work on for our audio. So I'm going to quickly show you what this demo scene is capable of so that you have an idea of what we're up to. So here we go. Start. So in our demo, we have a spaceship. If you click on the spaceship or click on the screen, you'll move your ship around. You can shoot things. Very classic vibes, you know. Very, very creative, new, thoughtful kind of a game, this one. But there you have it. Also, there are some power-ups somewhere around, here we go, that will level up your guns to more gunnish guns. And you can also explode. Let's do it. Very cool. And one of the useful things about this tutorial is it's got no sound at all. So good opportunity for us to make some noises. Great. Next up, if we want to get Chuck running for our thing, we need to start it up. So in order to get Chuck going in Unity, we can create an empty game object. I'm just going to call it Chuck, and it's done. No, just kidding. We need to add a component. There's a Chuck main instance, and once we've added this has added the Chuck engine to Unity, I guess. And then from here, we can create a number of subinstances of Chuck, which will talk to this main instance of Chuck in order to generate sounds. Also, we don't need to use microphone. In this, we're not going to use real microphone input to Chuck, but it's a useful thing to have. I don't know if you can hear that, but there is a motorcycle just started just below me in the mechanics. Okay, anyway, so we've got our version of Chuck. We've got Chuck up here, and we need to create a subinstance. And yeah, interesting to note that you can use microphone with this with Chuck and do all kinds of interesting things with that. But in this project, we're not going to be messing with that. So here we go. We've got Chuck, and we can create an empty game object. And this is where we're going to create some of this sound effect for our game. Also, I'm just going to create a kind of laser sound effect for this spaceship. I guess there's more things. Oops, I'm just going to close that. More things that we could experiment with. But for the sake of time and for the sake of simplicity of just getting a feel for how Unity deals with or how Chuck and Unity work together, we'll just make a single sound. I should also mention that I'm not really focusing particularly heavily on making beautiful sound design for this video. I'm just kind of focusing on getting real-time synthesis working and trying to use the most simple kind of code examples I can. So I'm not claiming this is going to be world-grade sound design. Not that I'd be capable of that anyway, but so yeah, it's simplistic stuff. And I should quickly mention while we're at this stage, some of the reasons you might want to use something like Chuck, this the language inside of Unity. So one of the great things about Chuck is one of the useful things about using Chuck alongside Unity is it gives you the ability to do really highly precise procedural audio inside of Unity. So which can be things like synthesizing audio in real time and triggering samples and so on at a really kind of granular, careful level inside of Unity. And while there are other pieces of software that do allow you to kind of do interesting audio implementation with Unity, there's not a lot of support for really highly granular procedural and real-time synthesis with Unity at the moment. So for example, while pieces of audio middleware software such as Wise and Fmod and Fabric do exist, which are kind of used heavily in the game industry, none of them have particularly broad audio synthesis capabilities or like individual sampling and so on abilities. So having something like Chuck kind of makes quite a lot of sense inside of a game engine, in my opinion, in that it kind of extends it into directions that are quite difficult without going really deep into writing your own audio engines in C++ or C# and so on, which is a big undertaking. So yeah, it's a really good way for doing real-time synthesis. So personally, in my past, I've used real-time synthesis for making things like rhythm games or games where the audio really has to carefully follow the action in the game in ways that just playing back stems of audio, so just playing back pre-recorded sounds that are mixed together in different ways, is quite hard to achieve. Really, really granular audio that changes moment by moment. Not that it can't be done. Like there's amazing stuff being done within that kind of taking linear chunks of music and then interactively changing between them and real-time mixing and so on. But I think there's certain situations in which really getting down to a note level or even a sample level has its uses in games. And it's been being used in games for a very long time. Like the original Game Boy games and so on were all done with real-time synthesis in engine, essentially. Well, actually, they were on a chip, but you know what I mean. Okay, anyway, continuing. We got halfway through something here. So we've got our game object. Let's call it. So this is going to eventually be our laser shooting sound. So let's just call it laser noise. How's that? Perfect. And we're going to create a Chuck sub instance for our laser noise. So essentially what it does is we've got an audio source that's being created on our laser noise and also a Chuck sub instance script. And so this means sound can be passed from Chuck through this audio source. We're also going to give it a reference to the Chuck main instance or the kind of Chuck audio engine here. I'm not going to spatialize it because we're working in a 2D environment here. This would allow us to go into, if you see it, it allows us to go into 3D and use the 3D sound settings from Unity and so on, but this is not going to be useful in this example. But it is important or useful to note that Chunity, sorry, Chunity does support the use of the 3D spatialization through the Unity engine spatialization tech. So good if you're doing 3D stuff. Okay, so anyway, we've got our laser noise thing here, and we need to create a new script, which is where we're going to write our audio code. So in order to do that, I'm going to jump into assets. In fact, we've only got Chunity, Scenes, and Space Shooter in here. I'd like to make my own folder called Scripts, where I can save any new scripts that I make. And in the script folder, let's create a new C# script. Let's create a new C# script and call it laser noise. Sorry, I'm using a Z in laser. I know that's breaking with the New Zealand tradition of using S's in these things, but hanging out in Germany for a year, everyone seems to be hooked on Z's rather than S's for some reason. I don't know. I'm being changed. Anyway, we've got laser noise here, and we can attach that laser noise script to the laser noise object by dragging it over to here. So now we've got a nice new script at the bottom of here called laser noise. Cool. So we've attached laser noise to our laser noise object here, and I'm going to open up this laser noise to edit the script. Sorry, open the wrong screen. Here we go. So also I should mention I'm using Sublime Text for my audio. Oh, sorry, not my audio. For my text editing. You can obviously use whichever text editor you like. I'm just a big fan of Sublime at the moment. So for our example, we're not going to need an update, and we can start by doing things inside of the start function. We might break it out into another function later, but let's just start with start. So in order to run code inside of Chuck from Unity, we have to do a few things. First up, we need to get a copy of the Chuck subinstance that was attached to the same game object as the script. So in order to do that, we can do get component, and get the Chuck sub instance. Okay, so that will get us a copy of the Chuck subinstance, and then from there we're going to run some code. So we've got a function called run code, like so. Then we're going to open up some brackets to run the code which we put inside of these brackets via Chuck, and we're going to do at and one of these, and make ourselves some lines to write our code inside of. I'm also going to make the same indentation as starting with where get component is. I'm kind of conceptualizing these brackets more like curly brackets because of the way in which they function, which we'll see soon. Also, it needs a one of those, what are they called? Colon at the end. Is this a semicolon? I guess it is. I should know this, I'm a programmer. Okay, anyway, going forward, I'm going to quickly show you how to get a sine wave up and running inside of Chuck. So yeah, from here we'll jump in and just do some kind of basic audio synthesis inside of Chuck, just to show how it works, and then I'll start to kind of move on to explicitly how it can interact with Unity Engine. So starting with basic sounds inside of Chuck, what is more classic than a sine wave? So we're going to create a sine wave. In Chuck, a sine wave is called a sine os. That's the object name, and we can give it a name, OSC for oscillator. Cool. And then what we're going to do is send this sine os with this funky looking set of characters to DAC. Now, DAC stands for Digital Analog Converter, and that will be the audio output for our computer, or whatever Unity is outputting audio to. In my situation, that's the system sound output, which for me is Soundflower. For my streaming, well, not my streaming, my recording setup. And you can, obviously output it to whatever you want. And also interesting to note that, this is using this interesting kind of special kind of streaming or sending sine which is that. And this is heavily used inside of Chuck, this way of sending values around. Next thing we need, let's set the frequency of the oscillator. I won't do 440 because everyone does 440. Let's do 441 hertz to OSC dot frick. Cool. So what this will do is it sends or assigns 441 to the frequency of oscillator. So note again, we're using this interesting way of assigning values. So normally in a C-style language, you would expect something more like os.frick equals 441. But if you write this in Chuck, you will get a compile time error because this is just not the way that Chuck does it. And I know that's kind of confusing to be using a kind of like, going against the norms of programming. But in some ways, it kind of makes sense in a musical and audio context, and that you kind of, for example, it's like sending an oscillator to the DAC, you're kind of routing audio, and just having DAC equal oscillator feels a bit, I don't know, it feels a bit strange for me. And so in a lot of ways, it works for the metaphor of audio signals quite well. When it comes to assigning values to numbers to variables, it's a little bit stranger, but yeah, I don't know. After a bit of playing with it, I'm getting pretty used to it. I still occasionally write it the wrong way around, but I don't know. It was a bit jarring at first, but I'm comfortable with weird assignments, weird assignment operators. Whoops. Oh yeah, by the way, I'm using a lamp as my mic stand because I left my mic stand at my studio, and I discovered a really cool thing with my with my new mic stand today. My lamp mic stand is that the springs on it make quite wonderful sounds, and if I pluck them like so, they resonate nicely in through the microphone. Whoops. There's a big one at the bottom as well. There we go, a nice little digression. Anyway, continuing on with audio programming. Very cool. So we've got our sine oscillator here going to the DAC, and we've assigned 441 to its frequency. Now, the next thing we need to do in the Chuck language is we need to pass some time in order for this to run. And the way that we do that in Chuck is we grab a number and we turn it into a duration, so 1 second, like so, and then we send it via the Chuck operator, and we chuck it to now. Don't ask me why we're sending seconds to now. I don't really know if I philosophically comprehend the reasons for this now, but this is how you deal with the passing of time inside of Chuck. So at this stage, we are ready to try it out in Unity, and we should have a 1 second sine oscillator. Cool. So we don't need the asset store up anymore. We can also keep console, but here we go. Let's have a play. Look at that. A quick sine oscillator, and then it's off. Cool. So some other interesting things to note when we come back here is, so currently we're doing 1 second, but we can also do a handful of different durations into this thing. For example, 1 minute. Minute will work. 1 hour will work. Even 1 day will work, I believe. I'm not sure if 1 year is implemented. I'm pretty sure 1 millennium isn't, but you could try. And it's also interesting, interesting that the devs have allowed things like 1 day. Oh, sorry, we've got a whoops. I think my clocks are out of sync. Every once in a while, I have to go through one of these weird noise sections. Do, 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 do. Much better. Anyway, very good. So yeah, we've got seconds, minutes, and hours. Also, we can go to smaller values like milliseconds, and all the way down to sample. And that's one of the really interesting and powerful things about Chuck. And what I was kind of mentioning right at the start of this video about it being able to do audio timing very accurately, Chuck can go, right down to a sample of accuracy just inside of its kind of main loop. So unlike a lot of audio programming environments where we'd be dealing with buffers of audio that we kind of manipulate and then send to some kind of a callback, Chuck simply works at a sample level if we need it to. And so for me, it's like one of the more intuitive ways of dealing with audio samples that I've come across in an audio programming environment. So yeah, anyway, moving forward, one sample, we're not going to hear much from that. I don't know if we'd even hear an audible click from that. So let's just, in fact we wouldn't because it's a sine oscillator starting at 0. Let's just go with 1 second anyway. And rather than just having it stop after a second, let's stick it inside of a while true loop so that we can try out some different things in here. Cool, so we've got a while true, every programmer's favorite thing to use. So this will go for all of time, and we will have a sine wave for all of time if we chose to leave it on for all of time. Well, I mean, I assume if I left it on for all of time, my computer would probably melt or my internet would get cut off. But if that didn't happen, that would continue for all of time. Wonderful. Next up, so yeah, that's sine oscillator. Also, I guess it's worth showing you the other basic types of other basic waveforms we can get inside of Chuck in case you're not haven't used the environment before. So we've got things like tri-os for a triangle oscillator. We can take a listen to that. Very good. We've also got a square wave oscillator, SQROSC. So I'm going to turn the volume down a little bit for the square oscillator because I assume it's going to be a bit loud. I should also, here's a good trick. So pretty much all of the different audio DSP modules we have, for example, square oscillators, square waves, sine waves. Oops, my microphone's falling over. Okay, mic's not falling over anymore. So yeah, what was I saying? Yep, I did that bit out. What was I saying? So oscillator, yep, so here's a good trick we can use with Chuck. We can set the gain of pretty much any audio DSP block that we can use in these kind of paths of sending things to the digital analog converter. We can grab OSC and do OSC.gain is now the gain member of the square oscillator class in this instance of it. And we can use our call Chuck operator to go 0.3 as a gain to os.gain. So that should get a little bit quieter. Okay, back to Unity. And we can hit play. Cool. Sounds like a square oscillator to me. And also you can do a phasor for a sawtooth oscillator, as you imagine. And also noise exists as well, which is useful. Obviously, setting the frequency of noise wouldn't work, so we'd comment that out. But yeah, there's different things that are possible. In fact, yeah, let's just do that. Here we go. Noise. Very good. Also, going forward from there, let's stick with tri-wave oscillator because that's what I'm going to use for my laser sound when we get to it. Going forward from there, other useful kind of classic building blocks of audio synthesis are things like envelopes. So there's a couple of envelopes inside of Chuck. There's the envelope object, which just gives you an AR envelope, but it's the API for it is a little bit funky to use, and I actually prefer to use the ADSR object for all my envelopes, whether or not I actually use the sustain release part of that. So yeah, ADSR stands for attack, decay, sustain, release, and is generally an envelope that looks a bit like, I'll draw it with my mouse, up, down, flat, and a release. Attack, decay, sustain, release. So we're going to create an ADSR object, and we can call it env for envelope and send it to the DAC. Okay, so we've got our envelope here, and now we need to decide how long our attack, decay, sustain, and release portions are going to be. Now, I really just want to have an attack, decay envelope. I don't care about the sustain and release, so I'm going to set sustain and release to 0 and set the attack and the decay to some values. I'm also going to I'm going to create kind of individual float variables for these things, just so that I can use them later. So, yep, one good thing to note with Chuck is that you can use classic floats, int, or float and int. I don't think it has a version of double. I don't think that would run, and it definitely doesn't have bool. So yeah, just floats and ints for our classic types. I think there's also string, but you'd have to look at the documentation about exactly whether it's capitalized and how to use these things. That it's got its own kind of implementations that are separate from C or C++ or any other programming language. But we're going to use floats for our attack and decay portions of our ADSR. So let's do maybe like a 10 milliseconds. Well, we'll just do 10 to float attack. Maybe attack. We'll just do attack. And for our release, let's say, I don't know, 60. Oops, 0.0 to float decay. And then we will set the other two to 0 and 0 for the sustain and release. So I'm not going to create individual variables for each of them. I'm also going to, while we're here, I'm going to create a third variable, which is the overall length of the attack and the decay summed together. This will be really useful later on when we start to need to know exactly how long our sound is. So let's go attack plus decay to float, laser length. I feel like I spend a lot of my life coming up with really boring names for things. But laser length, that's not too bad. This is kind of interesting, right? Anyway, we've got laser length with a Z. Okay, very good. And then we can jump in and actually set the length of the envelope's envelope. So env dot set is the function, and then we can enter attack for its attack portion, decay. Actually, one thing to note, these are in durations, just as this was in a duration type. So in order to turn these into duration types, we need to turn them to milliseconds, like so. It could be seconds or days or whatever as well, but I'm going to use milliseconds because these are in milliseconds. And then the sustain, of course, is an amplitude, so we're going to do 0.0. And the release is duration as well, but I'm just going to do 0 ms for the release. Cool, so we've set up our envelope. Also, we need to, so once we hit this while loop, if we just run it like this, it's going to be silent because we haven't actually triggered our envelope to open at any point. So in order to trigger the no tone for our envelope, we need to do env dot key on. Cool. So now we should have a nice enveloped tri-oscillator, a triangle oscillator in Unity. Let's take a listen. Very good. So getting a little bit close to a laser sound. Maybe quite a retro one. But obviously it's completely detached from the bullet firing of our spaceship. Stop that. Okay, so from here, we've got an oscillator, envelope, DAC. Might also be worth mentioning that there's a couple of other interesting objects we can throw in up here. For example, Chuck has a whole bunch of great filters. In my opinion, the easiest ones to use are the low pass filter, LPF, and the high pass filter, HPF. With them, all we need to do is create it, and then we can go. So we'll use this as our spot to set it up. Let's say 1000 hertz to filter.frick. Very good. Probably should have typed that. Sorry for the paste. I'm in automatic copy paste mode. And so that will, I'm sure you know what a filter sounds like. In fact, I'm actually going to leave that out because it's not, don't really need it. And also, what else is there? There's reverb, so we can do what is it? Just going to look at my cheat sheet to the right. In rev verb. Cool. And then it's got a parameter which is mix, so we can do 0.1 to verb.mix, like so. Cool, and so that should, let's take a listen to that. It's a pretty classic sounding algorithmic reverb. Oh, beautiful. Just like what space would sound like. Very cool. Okay, anyway, we're not going to need the reverb for our example. I'm just going to delete it. Delete. And is there anything else? Yeah, I mean, there is lots of other objects. Oops, just clicked my mic. There's lots of other objects out there, but for those that are interested, I would just jump onto. There we go. There's the sound of my springs resonating. Very good. Wait 1 second. For those that are interested, I would jump onto the Chuck documentation. I can just quickly pull it up again. But if we go into the unit generators part of Chuck, there's a whole bunch of different ways in which we can deal with kind of audio at a digital signal processing level. Like, what have we got? Delays and I don't know, chorus, and just lots of things you'd expect and such things. Also a whole lot of really great physical modeling instruments as part of Chuck. Because Chuck is built on top of this thing SDK, the synthesis toolkit, which is an awesome environment for C++ library with a lot of wonderful physical modeling created by Perry Cook. Also, another interesting thing to note is that Chuck also has a bunch of awesome unit analyzers, which allow us to do things like move from the time domain into the frequency domain and do some really interesting kind of FFT-based analysis and synthesis and so on, all the great stuff that can be done in that domain. If that's something you're interested in, it's all there and it all runs inside of Chunity as well. So give it a go. Anyway, back to Chuck, Unity. Oops, did I just quit that? Just going to reopen that. So with that like this, the next thing I want to do is hook it up so that whenever the laser in the scene fires, the sound will fire. So in order to do that, we need to go in and change things a little bit in here. We're going to add a thing called a global event, which allows us to trigger events from outside of Chuck, inside of Chuck. Also, I should note that this stuff is all indated incorrectly. I'm just going to pull it out a spot here. So, cool. We're going to add a global object, and we're going to call it, it's going to be an event type, and we're going to call it trigger laser effect. Cool. Okay, and we're also going to hook up this event to fire at the right time. So one cool trick we can do with Unity is that instead of passing 1 second to now and here, we can instead send an event to now, like so. Also, we're not going to need that 1 second in there, because it's just going to cause a note on. So now that we've got the event in here, and we've got this ready to go, we need to be able to send this event from outside of Chuck, inside of C# into Chuck. So in order to do that, let's make a new function called void FireLazer. Now I'm going to call it the same thing as the Unity function because I don't mind having matching function names across languages. If you do, feel free to name it something else. And yep, in our FireLazer function, we're going to have to jump in and get a copy of our Chuck sub instance. So let's do, get component. Maybe I should have made it a member variable, but anyway, this works like this as well. And we can go Chuck sub instance. There we go. Thanks, IntelliSense. And instead of doing run code, this time we're going to call broadcast event. Broadcast event, like so. Yep, and in here we will put the event name. I'm just going to copy and paste the name of this event into here. Okay, and in order to make sure that that runs, let's just call FireLazer and start. Also, we can. Oh, actually, we're gonna have to call. Sorry, we're gonna have to call FireLazer after we've set up the actual Chuck instance. We'll do it here. Let's see if that works. Well, let's make sure that it works. Cool. So that created a single beep sound the moment that Unity launched. Now, having all of my Chuck code inside of my start function is not the most beautiful place to put it, so I'm going to move it all into its own function. Let's go Command X, delete U, and make a new function. So let's call this void set laser sounds. Very good. And let's just copy and paste all of that into there. I think that looks about right for indentation. Yep, I'm just going to delete that bit of white space. Okay, and we're just going to run this function right when start runs. Cool, and just double check that that all compiles nicely. Should get a single beep. Very good. Okay, so from here, we need to find a way to attach this FireLazer function to the actual laser firing function inside of our Unity tutorial. Well, our Unity example here. So I've discovered this earlier, and I can say that the bullet firing sound, the function that calls whenever the player fires a bullet is attached to player, and it's in a function called player shooting script. So yeah, jump into your player prefab here, and we're going to open up the script here. So in order to open it, double click. Okay, so here we go. Here is the function. Sorry, here is the class that has the player shooting function. It's down here called make a shot. So we're going to want to call our function from laser noise from this here. The only problem is, if we go back to Unity, laser noise is down here, and player is here. So they're in separate object hierarchies. So we can't simply do get component to find the laser noise and the laser noise script. We have to instead do it a little bit of a different way, and in order to do that, we can jump up here. We've got our different public objects, and we can go public game object. Oops, bit of weird noise there. Yep, public game object, and we can call it laser noise object. Very good. And from there, we can jump down here and do laser noise object dot. Then we can get the component laser noise script name function, and do our FireLazer function from laser noise. Cool. So I'll make a space. So jumping back to Unity. Now, once this reloads, player should have a new, come on. Maybe there's something wrong. What have we got? I see the problem. So it's saying FireLazer is inaccessible due to protection level. That's because I need to make the FireLazer function public. Oops. Public, like so. Okay. Now it should build. Cool, very good. And we've got our variable player shooting has not been assigned. Yes, that's correct. We need to go in here, player shooting, and find our laser noise object, which is here, and drag it onto here. So, also, I'm going to go in here and remove the call to FireLazer and start, because we're now going to be calling it from player shooting instead. And let's take a look and see if this works. Very good. Look at that. Awesome. Okay, so now that we've got our function up running nicely and Chuck running inside of Unity, let's see if we can add the ability to input variables from Unity and get them across into Chuck. And this will give us a lot more control of kind of musical parameter changes based on gameplay, which is a really useful thing to do. We have 4 different layers of laser on the player. I actually accidentally started it at 4, so we're going to move that back to 1 as our starting power. So when we start playing, we have individual things coming out. And something really simple we can do to make this a little more interactive or different is that when we power up our lasers to different levels, we can change the frequency. So starting at 441, we can move down by, I don't know, let's say 50 hertz for every new power up we get. Just as an easy example of how we can get parameters into Chuck. So in order to do that, we need to create another global parameter, just like we have the event. So I'm going to create a new global parameter. Instead of an event, I'm going to create a float. And we're going to call this, what should we call it? Laser pitch. That should do the trick. I don't think what was our previous one called? Yeah, there's no other name. So yeah, laser pitch seems perfect. Yep. And when we call our FireLazer function, let's add a pitch parameter for that. So we're going to float pitch. So the next thing to do is that when we call FireLazer, we need to input this pitch information. And so for that, we can do laser pitch and enter it into here. This also means we don't need this oscillator frequency startup stuff, but I'm just going to leave this in place for now because it's it means that we don't have the possibility of having weird intermediary values or anything. So anyway, let's jump back and try running our FireLazer function slightly differently. So now, when we're in here, we've got the FireLazer here. Now, these are the 4 different cases for our different types of guns, or different kinds of lasers. We have 1, 2, 3, or 4. So one good trick we could do is we could set the pitch of our laser noise in here, and then instantiate or create that sound when at the end of this function. So in order to do that, I'm going to move this function here right down to the bottom, like so. Boom, 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 boom. Like so, make it a little lower, and then set up a temporary variable. Let's do float, laser pitch, like so, equals. In fact, we don't need to do equals here. We can do that in here. And then in each of these cases, we can set the pitch to something else. So for example, you can set this to whatever you want, but I'm just going to go, let's do 5, equals 500, if 400, let's do 450. I said I would do 50s. That's right. I'm just going to copy and paste and do this. Oops. That's so 500, 450, 400, and 350. Oops, that's weird. There we go. And finally, when we come down here, before we actually call the FireLazer function, like so, we need to jump in and set the pitch of our signal. So in order to do that, we can do laser object dot get components laser noise dot, and we're going to go get component again and do chuck sub instance dot, then what was the name of our value? Laser pitch. So we can do dot set float laser pitch, and then we can set it via using our function or our variable name. So laser pitch here. Cool. Let's give that a play. Oops, what have I done? Unassigned local variable. Okay, let's set you to 500 to start. Oops, and we can make these all floats. Don't know if it needs it or not, but may as well. Okay, so this should be our 500 hertz. Let's wait for a level up. Here's one. And it didn't work. And the reason it didn't work here is because we need to actually set the frequency inside of this function as well. So we can do pitch, pitch to os.frequency. So jumping back, oh, what have I done? Line 19, we've got an error. Or 28, that sounds more like it. 19. Oh, yep, I put 2 of these one after the other. Much better. Cool, let's run it. That's more like it. That sounds like a higher pitch to me. Okay, let's wait for a power up. Here we go. We've got a different pitch here. I did say it wasn't going to be the most amazing sound design in the world. Now you can see that I was right. Very good. And we should have another power up turning up any second now. There we go. Lower pitch. And finally, the lowest. Cool. So, that was my Unity, Chuck and Unity tutorial via Chunity. There's all kinds of other things you can do. Obviously, this was a very simplistic tutorial just to give you a feel for the kind of code required to get this up and running. It's also worth noting that there is a Chuck tutorial that's available, a Chunity tutorial. If you go to stanford.edu/Chunity/tutorials, a lot of the information I'm giving you here kind of came through this tutorial, and it's really great. Also, if you're part of the AGJam that's going on at the moment, feel free to stick around. I'm going to be hanging around in the chat from 9 a.m. to 11 a.m. European Central Time. I don't know, or Central European Time. I don't know what that is in your time zone, but whatever it is, I'm going to be hanging out in the Discord chat and happy to answer any questions you might have about Chuck and Unity. Thank you very much.